This section on the Integumentary System chapter is going to consider pigmentation in the context of a case study. This is a simple case study of a child with a change in the coloration of his skin. Let me give you a chance to read through it. This is a picture of the patient described in the case. He's from Sri Lanka, which is an island region off of the Indian coast, so he has a naturally brown-colored skin. And we see here that there's a patch of discolored skin along his chin up to his lip. There's another patch down at the bottom on his neck, which might represent an early stage of what happened in the earlier 18 months that this case is suggesting this has been happening. Consider this question. When you feel that you've reached an answer, hit the next button to go into the next slide, which will reveal the correct answer. The cell that's responsible for producing the molecules making color in the hair and skin is the melanocyte. Now in the question, I've suggested a plural of molecule because in fact there are multiple types of molecules that are made by melanocytes. The molecule is generally referred to as melanin, but there's actually two types. There's eumelanin and pheomelanin. And there's a differentiation between the molecular structure in those two, but then within eumelanin there's actually two different types based on what they actually look like color-wise. There's black eumelanin and brown eumelanin. Melanocytes are found in the stratum basale, the lowest level of the epidermis, and they produce melanin molecules. The cells have extensions of the cell membrane that reach out and pass between the keratinocytes of the lower layers of cells. And it hands off melanin within membrane-bound sacs called melanosomes that are incorporated into the cell. And some cells will even have more melanin in them within the cytoplasm. There's also melanocytes found at the base of hair where they're growing in this hair follicle, and they do a similar thing to the keratinocytes that make up the hair shaft itself. Now, eumelanin produces black or brown versions, which will have an effect on the different tones within the skin and hair. And then there's also pheomelanin, which is a reddish pigment and will have an effect also. Now, there are certain areas in the skin that are particularly reddish in color, and so they get that pheomelanin in them. But it also will help make for certain tonal differences in skin and hair. So, for instance, red hair obviously has a higher incidence of pheomelanin in it, giving it that color. This figure shows what a pigment molecule does. Light is shown upon the substance that contains the pigment, and it's going to have all of the different wavelengths of light represented, all the different colors that we can see in the visible spectrum. And the pigment will absorb some of those wavelengths and reflect others. And so whatever color we see that we associate with that pigment includes the wavelengths that are reflected. Now, for a black pigment like eumelanin, what's absorbed is all visible spectrum light. And so nothing's reflected, it has a black appearance. Eumelanin also absorbs UV radiation, which is slightly higher energy wavelengths that aren't visible, but they're still in that same relative area of the electromagnetic spectrum, and those are absorbed also, which is what gives melanin its protective quality by keeping UV radiation from getting deeper into the body. The case study that this discussion is based on, of the boy with the widening patch of white under his lip, is a condition called vitiligo. It's often most obvious in people with a darker skin tone, although it certainly happens in people with lighter skin tones. I had a friend in high school with vitiligo, and it created problems in the summer because she liked to go out and tan, and she had big white patches on her knees, basically, and thigh. And so she couldn't tan the way she wanted to because it would really accentuate that color difference. Plus, having vitiligo means that the melanin-producing cells, melanocytes, either aren't working properly or have been destroyed in that area, which removes the UV radiation protection from the skin at that area. So really it's not advisable that my friend would have even wanted to go out into the sun at the time. Probably one of the most famous examples of vitiligo is Michael Jackson. There's certainly a lot to be said about the apparent lightening of his skin over his career, which apparently was a cosmetic solution he came up with to deal with the fact that he had vitiligo. And his autopsy confirmed that that was in fact the case and supported that claim that he made when he was younger. Consider this question. When you feel that you've reached an answer, hit the next button to go into the next slide, which will reveal the correct answer. The version of melanin that gives skin and hair a reddish color is called pheomelanin. Actually, in red hair, there's a little bit of the brown eumelanin at levels that would normally make hair blonde, but adding pheomelanin to that makes that hair red. And then in certain areas of the skin, such as the areolae around the nipples on the breast, there's pheomelanin making it a reddish kind of color.